Alright, in geometry we talk about something called the segment addition postulate. Before I get started, let me talk about what that means. So let me draw another segment on the right, something like this, and I'm going to divide this into three points. Say point A, say point B here, and point C on the other side. The addition postulate tells us that if I were to break this up into two parts, say segment AB, and then add them back together like this, segment BC, together they would give me, of course, the obvious, which is the length of segment AC. Okay, so the sum of the two parts of the segment gives me the whole segment back. So this is what we're going to apply for these problems. So here we got the first part. It says that the first part from G to H is 2x minus 3, so we're going to apply that here. So we're going to go 2x minus 3 plus second part, which is HI, will be positive 7. And then the AC part, or the whole part, GI, will be equal to 3x minus 3. And the rest would be to solve for the x first, right? We combine like terms, so we're going to get 2x, and then 7 take away 3 is 4. And that's equal to 3x minus 3 here. And then subtract 2x from both sides, that only gives me an x minus 3 there. And then I4 there, and we can see that's a 4 here. We see that if I add 3 to both sides, then x would be equal to 7. And then you are to find the length from G to H. So if I want to find G, length GH, by the way, length of a segment is written in this form without the bar. So the length of the segment is supposed to be 2x minus 3, but we already know what x is, x minus 7, so we substitute 2 times 7 minus 3, that's 14, subtract 3, which is going to be 11, so this is equal to 11. So let me put that in a box here for you. Okay. Now, the second problem, I have a similar problem like that, and this is going to be from point, I'll put this in red, point C to point D here, and then we have point E, and we're going to apply, the total length from here to here is 21. Now this is not really the center. We don't know where the center is, but we don't need to find the length CD. So this length is 21. This over here is given that it's x plus 19, and the other part x plus 20. So this is x plus 20. Again, applying the rule of segment addition, so we're going to sum these segments up, which we get, let me go back to a different color here. Let's try green for a change, because if we have x plus 19 for the first part of the segment here, added to x plus 20, and then the sum of both of them will be equal to 21, and then we can clearly solve for x really fast. So x plus x is 2x. 19 plus 20 would be 39, and that gives us 21. And then subtract 39 from both sides. Okay. X plus 19, x plus 20 is 21. Yes. And then subtract 39 from both sides. That what gives us. negative 18, so we're going to have 2x is equal to negative 18, and then of course we can see that x is going to be equal to negative 9. Now you probably are worrying that, oh, how can x be a negative? Well, x can be a negative but not the segment. So if we substitute, if we want to find the length from C to D, which is given by CD is given by x plus 19, and subtract 9 from both, so that's going to be this should be negative 9 plus 19. This gives us positive 10. So that means that CD, the length CD, is equal to just 10. And we have one more, and let's see. This one is very similar to the previous two, in which this part here would be point T. This point here would be point U, and the last point over here will be point V. And using the same postulate, TU, it's always a good idea to write the postulate to get used to the fact that we are using a postulate. TU plus UV is equal to TV. And then this part here is given to be as x plus 3, and then positive 5 for this length, and then the total length from here to here would be 2x plus 2. So we get 2x plus 2 here, and upon solving for x, we substitute that into our postulate here. Then that gives us x plus 3 plus UV would be the 5 plus 5, and then the TV total would be equal to 2x plus 2. So 2x plus 2 is our total, and then solving for x, so we can combine like terms always. X plus 8 is 2x plus 2. Subtracting x from both sides, you can see that doing the algebra correct is very important. This was 8 is equal to x plus 2, and then what number plus 2 gives me 8? That would be x equals 6, right? Now once we know what x is, we can go ahead and substitute and solve for our length, which we're looking for is TU. So what is TU here? We just substitute. Let's try a different color for all time's sake. Let's try maroon red. So this was x plus 3, and then since x is 6, so we're just going to substitute 6 plus 3, which is of course oops, little typo there. Go back a little bit. Go back, and since x is 6, this should be 6 plus 3, which is total of 9. Okay, so that's our length TU. And that is a simple examples of segment addition postulates.